All right, so let's pick up where we left off with some more example problems from Chapter 7, the orientation tolerances. And here we're going to look at problems that are based on the ones from your study guide. Okay, so what I've done is I've changed some of the numbers around so that I'm not doing exactly the problem that you're going to be working on, but I think I'll try to keep it close enough so that at least you'll have an idea. And it will help you in finishing those problems. So the first one that we're going to look at is this one here, and I'll read this. It says, apply a size, dimension, and tolerance to permit the slot width to vary by 1/10 of a millimeter total, and apply geometric tolerances to require the sides of the slot to be parallel to one another within 40 thou millimeters total. Or 40 thou millimeters. Okay, so and the geometry that we're doing this in, I'll draw this again. I'm going to purposely change some things so that it's not exactly like what is in the book. So we'll make it look like that. All right, and actually, this problem has posed some confusion in previous semesters. So there's actually two things that we have to do here. So first, we're applying a size dimension, all right? And then the second is we're applying a geometric tolerance. So we're actually doing two things here. We're adding two types of dimensions or tolerances. So let's take the first one. Apply a size dimension and tolerance to permit the slot width to vary. So we're going to be dimensioning the slot width here. And the number doesn't matter. All right, they don't give you a number, so I'll just make up something. We'll say 10 millimeters, plus or minus. Now it says to vary by 1/10 of a millimeter total. So if I'm going to do a plus minus tolerance, then to get 1/10 of a millimeter total, I want to do 0.05 millimeters on my plus or minus. Right, that will give me 1/10 of a millimeter total. Obviously, there's other ways you can do this. You could say plus 0.09 minus 0.01. You know, any variation within that. But this is just one of those variations. Then it says to apply a geometric tolerance to require the sides of the slot to be parallel to one another. So we're going to apply a parallelism tolerance. But how are we going to do this? Apply the geometric tolerance to... So if we do this, if we put a datum here, right, then remember that this, applying a datum right opposite the arrow establishes a midplane. There's nothing in here about a midplane. So we actually don't want to do this, right? Remember that it's very important that we place the datum identifier in the proper location. So what we really want to do is we want to identify one edge or one side of the slot as a datum. And I'll do this here. And then to require the other side to be parallel to it, I just need to parallel 0.04 relative to A. Okay, so the crucial thing here is that we're not identifying a datum midplane. Right? And that means that the datum identifier here is not going to be associated with the dimension, the arrow, the size, anything like that. Okay? So this says this side of the slot will be parallel to this side, right? Parallel to A. All right? So that's that. All right? So let's move on to the next one. The next one says to apply a basic dimension between the shown holes, and I haven't drawn it yet, so I will in a second. Establish one hole as a datum feature. Apply a tolerance that defines a parallelism requirement between the holes to 50 thou millimeters when both holes are at MMC. There is more than one acceptable solution. Okay, positional tolerance requirements for the holes are not included, right? We're not doing positional tolerance. And then you're given some information like this. All right. Now, let's get the geometry in here. All right. So I'll just draw something that looks like this. The shape is not really critical, and we'll put two holes like that. All right, so let's take this one at a time, these features in here. So first up, apply a basic dimension between the shown holes. All right, that's going to be pretty easy, right? And again, we don't really care what the basic dimension is, so I'll just put XXX in there. Okay. Establish one hole as a datum feature. Okay, so it doesn't matter which hole we apply as a datum feature. Okay, but it does say that hole number 2 is the controlled hole and hole number 1 is the datum hole. All right, so it doesn't say which hole to apply as a datum feature, but here we're going to apply hole number 1 as the datum feature, and that's this side. So we can do that by just pointing to it like this. And saying that that is A. Okay? So that's one way to do it. We're calling out this whole feature as a datum, which means we're establishing a datum axis through this hole. Okay? Continuing to read, apply a tolerance that defines a parallelism requirement between the holes to 50 thou millimeters. Okay? So if we want a parallelism tolerance between the holes, then we're going to be, and I'm going to go ahead and I'll kind of purposely do this wrong just so we can talk about it. There's the size dimension for that hole, right? And parallelism, we want the axis of this hole to be parallel to the axis of A. So there's A at when both holes are at MMC. So so that's going to be let's see, cylindrical feature 0.05 at MMC. Okay, so and then I gotta change this and add MMC here. Okay, so let's just look at this. Okay, so we're controlling this hole relative to this hole. All right, it says to apply a parallelism tolerance. This is a cylindrical feature of size, so we need the diameter symbol. And it says when both holes are at MMC, so we need this MMC here, but we also need an MMC on the A because datum feature of size A is the hole. Okay. So that's all good, but here's where the problem is. So you might say, well, wait a second, these holes are the same size, so why don't we do this, right? Well, that's precisely what's wrong, all right? You can't say 2 times here because that means that this parallelism is on this hole and on this hole. And clearly this hole is the datum, so you can't self-reference a parallelism tolerance to a datum. So this 2 times cannot be applied there. And in fact, if you were going to dimension this hole, you would have to dimension it separately. Okay? Which is no problem. That's perfectly acceptable. Okay? The other way to do this would be to separate the datum, separate the feature control frame. So the other way to do this would be to, let's draw this real quick. The other way to do this would be to say this hole is parallel 0.05 at MMC, A, MMC. And then we can call out this hole to be 2 times diameter 10 plus or minus 0.02. Okay, so in this solution, we are separating the feature control frame from the 2 here. All right. So in this way, we have to have 2 size dimensions. Here we can use 2 times, but we have to pull this out and make it separate. This, of course, doesn't change. This still is A like that. Okay, and of course the basic dimension is the same. Okay? All right, so moving right along, I'm going to try to conserve some paper here by turning this over. All right, complete an interpretation drawing that shows the required datum in the perpendicularity tolerance zone. All right, now in this problem, we just have a block. And we'll call this X. And this is perpendicular to X. And we'll come up with some number. Let's say 0.04. Right? So what is the interpretation drawing for this? Well, let's draw this again, but let's draw this surface a little bit more loose. Okay. So the datum is going to be here. The tolerance zone would be here. And the tolerance zone is 0.04. And the tolerance zone is going to be perpendicular to A. Okay. So as long as our surface lies completely within this 40 thou tolerance zone, then we're good to go. All right. All right, so let's do the next one here. Complete an interpretation drawing that shows the permitted variation of the axis and the surface. All right, and I think this drawing see, we have a feature with a hole through it, and I'll draw this as a section. So an interpretation of this drawing, if we're going to be, let's say XX, diameter XX, and perpendicular to A, we'll say this is 0.05 at MMC. and then this is A. Okay, an interpretation of this, we would have a tolerant zone around the axis. The tolerant zone would be perpendicular to the datum plane A, and the diameter of the tolerant zone, it is a cylindrical tolerant zone. The diameter of the tolerant zone would be 0.05. Okay? So that's the interpretation drawing for this. All right, now let me get, we got two more to do, so let me get a fresh sheet of paper. So the last two, apply a perpendicularity tolerance that results in 12.07 millimeters virtual condition from the pin. All right, so what's missing in this is the diagram, the drawing. So let's draw this. And we just have a simple pin. And the diameter on this pin is 12 plus 0.02 minus 0.04. Okay? And what we want is a virtual condition of 12.07. All right, so we want to have a feature control frame with a perpendicularity tolerance. Now, the perpendicularity we can say is applied to this top surface. We'll say B. Okay, perpendicularity. This is a cylindrical feature size, so we need a cylindrical tolerance zone. This number, what's going to go in here? Well, if we want a virtual condition of 12.07, then we need to figure this out based on the virtual condition equation. So let's work through the virtual condition equation. The virtual condition, this is a positive feature for a positive feature, is equal to the size at MMC, size at MMC, plus the tolerance at MMC. This is the number that we're trying to find. We know the virtual condition is 12.07, right? That was given. And we know the size at MMC is, well, this is a positive feature, so the size at MMC is 12.02. So what tolerance will make this equation true? 12.07 equals 12.02 plus what? Well, the tolerance in this case is going to be 0.05, right? 0.05 plus 12.02 equals 12.07. So the tolerance at MMC is going to be 0.05 MMC relative to B. All right. And last but not least, all right, complete a feature control frame that controls perpendicularity of a hole to datum feature A and straightness of a hole to some tolerance value. Okay, so we have two things going on here. We're going to have a two-line feature control frame like we had in the last example. So if we have, let's draw our feature right here, what we're trying to control. So draw something like this. All right. And we want, so this is the hole. Complete a feature control frame that controls perpendicularity of the hole. So let's establish where we want it perpendicular to, and I'll make the bottom plane datum A. So now we want this hole, and it doesn't really matter the size of the hole, xxx plus or minus xx. Okay. Perpendicular to 50 thou at MMC. Perpendicular to A. It's a cylindrical feature of size, so we need a cylindrical tolerance zone. 0.05 at MMC. All right. So that says make this hole perpendicular to A with a tolerance zone of 50 thou at MMC. Then it goes on to say, and straightness of a hole to 20 thou at MMC. Well, remember, perpendicularity or orientation tolerances are a level 3 tolerance. Straightness is a form tolerance, which would be a level 2 tolerance. So we would put that underneath this, and it would be straightness. It's a cylindrical feature of size, so we need a cylindrical tolerance zone, 0.02 at MMC, and that's it. Okay, no datum reference here. This is a form tolerance. The straightness goes under the perpendicularity because this is a level 2 tolerance, and we always go in the order from highest to lowest. Okay. All right. So there you go. I think those examples will help you do the problems. Hopefully with this chapter, things are starting to come together. I think the orientation chapter is one that in the past allows a lot of intuitive understanding of the concepts to really take hold. So I hope that happens. Please remember, if you have any questions, to send me an email, and I'll be more than happy to help you out. All right. So, all right. So now it says, apply a basic dimension between the shown holes. Establish one hole as a datum feature. Apply a tolerance that defines a parallelism requirement between the holes